It is Thursday, so I hope you guys are dressed up as your favorite superhero. I can't wait to see those pictures. I am talking to you guys not as Miss Adams today, but actually as Blackbird, my superhero. You guys know um, how I can go back and forth. So that is who I am today on Superhero Day. I am Miss Blackbird, not just Miss Adams today. So we are going to go ahead and continue talking about the bottlenose dolphins. We are currently answering this big question in our chapter 2. We are trying to figure out, how does sound energy travel? And so yesterday we were able to do some observations. We were able to investigate, and we found out that sound can actually travel through different materials. Yesterday, we found out that sound can travel through your hand by tapping your hand over your ear. We found out that sound can travel through the air by way of our voice. And I hope you guys tested out some cool things yesterday in the house and figured out some other ways that sound can travel through. For example, if I were to knock on the door, I would know that sound can actually travel through wood, right? Sound can travel through furniture. So sound can travel through a lot of different materials. Today, we are going to get a little deeper into those materials, right? What make up materials? What does it look like? Because it happens in a way that we can't actually see it. So we're going to look at some diagrams today, and we have some vocabulary today that's going to help us understand why we can't actually see the sound energy traveling all around us. Let's go ahead and get into our first vocabulary word for today, which is particle. What does particle mean? Particle is a tiny piece of material too small to see. We're going to get into the text as well as our simulation today to look at some particles. Hint, hint, nudge, nudge, when we think about that simulation and what those dots represent. And our next vocabulary word for today is vibrate. So what does vibrate mean? Vibrate means to move back and forth very quickly. So when you put your phone on vibrate, here you see the little icon. When our phone vibrates, it actually shifts a little bit. It's moving back and forth so quickly that it's not even allowing itself to sort of move all over the place, but it is moving very fast, very quickly. I want us to get into our classwork before we actually log into our simulation so we know what we're doing when we get into the simulation. Here's our classwork. As usual, you have all your resources here in black. You have your book, Sound on the Move, which we're going to get to after our simulation. You have your sim. This is how you access the sim. You are going to click this link here. When you get to this link, you're going to go to the orange number 1, which is sound waves. When we get to the directions, we will go through those steps again so you can see what it's like, what it looks like. Our objective for today, I will be able to identify and explain patterns and particle motion as sound energy travels. So we're going to do some more observation when we get into our sim, and we're going to sort of investigate a diagram in Sound on the Move to sort of really have a clear understanding of how particles work. As usual, in blue, you have your vocabulary words. Please use these vocabulary words to when you are writing definitions in your PDN. For your PDN today, you have a scenario. In this scenario, talking about my big brother Chris here. Imagining he was in science class when he was your age. This is what happened in one of the science classes. You're going to answer these 3 questions about Chris being in science class and falling asleep. And then here you have your regular definitions, which again, I would like for you to use the definitions in blue. This is what we want to sort of do together / independently. I am going to do an example for you when we get into our sim as to how you should write down your observations when you think about what you see and what you hear. So let's go ahead and jump into our simulation now, actually, by following these directions. So you're going to select the instrument in the sound wave simulation. You'll then press play and observe what happens using your eyes and ears. And you're going to record the observations of what you see and hear in this box, in this column. So in this column, you'll type in your instruments. In this column, you're going to type in your observations. So to get to the sim, you will click this link here, and that link should bring you to this page. If the link brings you to the page where you have to log into Amplify, please go back to your Google Classroom and find the information that says Amplify Login Information Sheet. That gives you the login information that will give you access to this page. You're going to look for the orange number 1 titled Sound Waves, which is right here. Click on that. After you click on that, you are now in the simulation. For our class assignment, I want us to actually focus on the cello. So I am going to click on View All Sounds. I'm going to click on the cello here, and then I am going to observe the cello. Now, before I actually press play, I want to type in so I can remember what I'm focused on. I'm going to actually type my instrument in here, which is the cello, making sure I spelled it correctly because it is actually right there for me. And then I'm going to press play, but I have my paper and my pencil next to me so that I can jot down some notes. So as I play it over and over again, I'm taking down notes and noticing what I'm observing. What am I seeing and what am I hearing? So I'm going to go ahead and press play now. Again, I have my pencil in my hand and I'm ready to jot down any notes of what I'm going to see and what I'm going to hear. So I'm seeing a lot of little orange dots bouncing all over the place. I'm going to make that note down on my paper. I'm also seeing 2 vertical lines. These orange dots are forming and stacking on top of each other and forming 2 lines. Those 2 vertical lines seem to be sort of tightly stacked. And while those vertical lines are stacking, they're still shifting towards the left with dots still moving around them. I also see dots sort of crashing into them from both sides. And now I'm going to think about what I hear. To me, the personal connection that I can make, it actually sounds like if I'm on the expressway and I hear a truck sort of like honk its horn or something. That's what it sounds like to me. Yeah, so definitely sounds like a truck blowing its horn. It is also very deep to me. As if someone is trying to make noise. So it's a very deep one. So I'm going to come back to my classwork and I'm going to write down everything that I observed. And for this, I'm going to go ahead and use what we would know as bullet points. So to do that bullet point, all I did was click on the subtraction symbol, which is above in the numbers. And I'm going to go ahead and start typing. So what I saw orange dots moving all around. I pressed enter. It's going to give me my next bullet points. I also saw orange dots stacked on top of each other to form 2 vertical lines. And what I heard, so I heard a sound that sounded like it came from a truck blowing its horn. It also sounded very deep to me. And so that's my observation for the cello, right? I saw orange dots moving all around. I saw orange dots stacked on top of each other to form 2 vertical lines. I heard a sound that sounded like it came from a truck blowing its horn, and it also sounded very deep to me. Now, you are going to choose 2 different instruments and then write down what you observed. But if we wanted to compare, because it sounds very different from if I were to choose a violin and compare it to the cello, my observation would be different, right? Now I'm not seeing 2 vertical lines, but now I'm seeing at least 4 to 5 vertical lines that are forming while orange dots are still moving around. And it's no longer a deeper sound. It is actually a very high-pitched sound that I'm hearing. So your observations should be different based on the instruments that you choose. Because if we were to say, let's choose the drum, it's going to sound completely different. And those vertical lines are not as tense. It's not as many stacked on top of each other. So make sure when you are writing or typing in your observations, you're really thinking about what you see and how it's different from the other instruments. We're going to go ahead and move on to our text. You are going to have to answer these 2 questions. What do you notice in the diagram on page 9, as well as how does this help you explain what you observed in the sim? And that box is right here. So I'll sort of shift that for you guys. But as we read page 8 and look at the diagram on page 9, please know that you're going to have to answer those 2 questions, because page 9 is going to help us understand, well, what are these orange dots, right? Why are they moving around when we are in our simulation? So let's go ahead to sound on the move. Page 8. How do messages travel through the air, water, and ground? Many animals send sounds through the air just like us. Others communicate underwater, just like the dolphins. Some animals even send sounds through the ground. The air, the water, and the ground are all materials. So is everything else you can touch. Materials are made up of millions and millions of tiny pieces called particles, which is our vocabulary word today. Particles are too small to see, even with a microscope. We can't see particles, but we can visualize them. The diagram on the next page can help. Particles can move. Even in a solid material like the ground, the particles can move a little bit. Animals send out sounds by moving the particles that make up materials like the air, water, and ground. Let's look at some examples of animal communication. We'll zoom in on this invisible world of particles to see how sounds travel through different materials. Let me go ahead and zoom out so we can go ahead and take a look at this diagram. So we have 3 different images here. And I'm noticing here, when I think about answering this question and what you notice, what do you notice on page 9? I am noticing that in this first illustration here, I'm noticing blue dots. I'm noticing there are a lot of arrows, and I'm noticing these blue dots are not all stuck together. When I get to this illustration, I'm noticing that there are a lot more blue dots. I'm noticing that these arrows are actually curving, and these blue dots are actually closer together. Now, when I get to this third illustration, I'm noticing that the blue dots have actually formed into a shape, right? This looks like a 3D shape here. It looks like a cube. And I no longer see arrows, but I do see these little symbols that you typically represent movement in some way. So we went from having loose blue dots to they're getting tighter and there's more of them. And now they have actually formed into a shape. And so I want us to think about what those blue dots represent, right? When I think about the particles, I think about, and I think about this diagram, I'm actually thinking about this being an example of how particles look. And because they're so tiny, we actually don't get to see them. But here, we know that this represents the air. We know that this represents water, and we know that this represents the ground. So when we look at the diagram, we know that in air, water, and the ground, there are particles in all of those materials. However, the particles are so small that we can't see them, but they still do exist. And this is how they exist, and this is how animals are able to communicate like us, and these particles go from one place to another. When you think about these blue dots and you think about your classwork and this question, how does this help you explain what you observed in the sim? Those blue dots are very similar to these orange dots. And so if those blue dots are particles, well, what would you consider these orange dots? That's what you want to answer in this question here. Go ahead and think about summing up this big question. Today we learned that materials are made of particles that are too small to see.